Ionic bonds. Whenever an atom forms a compound, it is attempting to get a full, stable outer shell of electrons, which, as we know, makes it follow the pattern 2, 8, 8. If it has one shell, it wants 2 in its outer shell. If it has 2, it wants 8. If it has 3, it wants 8. The easiest way for them to do that is to either lose their electrons in their outer shell, making the next one down the full outer shell, or gain enough electrons to fill up that outer shell. And which one they do depends on their position in the periodic table. Metals lose electrons to form a positive ion. Remember, electrons have a negative charge, so if you lose them, you end up with a positively charged ion. The non-metals, except for hydrogen, gain electrons because they are trying to fill their shell up. If you gain electrons, you end up with a negative ion. Electrons have a negative charge. But eventually they will get the same electron configuration as one of the noble gases, which means that they will be stable. Now when they do this, if you react a positive ion and a negative ion, a metal with a non-metal, you will end up with various combinations of positive and negative. Opposites attract, just like a magnet. If you've got positively charged ions and negatively charged ions, they are going to stick together. We call this an electrostatic attraction. A classic example of a compound that is held together by ionic bonds is common table salt, sodium chloride. The sodium loses one electron to form a positively charged ion. The chlorine gains that electron to form a negatively charged ion, which we can represent with these dot and cross diagrams. Notice I've used a different dot or cross to show which atom the electron originally came from. The sodium has a positive charge, the chlorine has a negative charge, the electrostatic attraction sticks them together. Now they end up forming giant ionic structures like crystals, which we'll cover in a later lesson, but the short version is the opposites attract and stick each other together. That helps us to build the formula of ionic compounds that we may not have seen before, because the overall charge on the compound has to be 0. So in sodium and chlorine, we've got sodium forming a charge of 1+, it loses 1 electron. Chlorine forms a charge of -1 because it gains that 1 electron. And if you have +1 and -1, that's neutral. So every time you have 1 sodium, you have 1 chlorine. The simple formula for sodium chloride is NaCl. However, ions sometimes form that have more than one charge. Here is an example. Magnesium is a metal in group 2 of the periodic table, and it forms a 2+ charge. Chlorine, as we mentioned before, has a -1 charge. If we want an overall balanced molecule, then every time we have 2 positives, we have to have 2 negatives. I get 2 positives from 1 magnesium ion, but I only get 1 negative from 1 chlorine ion, so the ratio has to be 2 chlorines for every 1 magnesium, giving us the formula for magnesium chloride of MgCl2. So overall, remember, metals lose electrons to form positive ions, non-metals, except hydrogen, gain electrons to form negative ions, the molecules are stuck together with an electrostatic attraction, and the molecular formula for an ionic substance has to balance the positive and negative charges.